In this video, we're going to start moving around our sine and cosine graph. These things are called sinusoidal waves. Cosine also fits in here, but we just lump them all together into sinusoidal. Kind of fun to say. And then waves, because we know our sine and cosine graphs are waves. So we're going to break down the transformations of sine and cosine into very small parts, one at a time. The first one being the midline. Just make sure you know those sine and cosine graphs. And transformations, we learned before. We've had problems like this. All right, this needs a base. We've had problems like this. All right. And we learned that the values near the x move our graph left and right. The values away from the x move our graph up and down, and negatives flip it. All right, we're going to do basically the same thing with sine and cosine. All right, we're just going to break it down into smaller pieces. All right, so we're going to graph sine of x minus 2. Again, whenever we're graphing a function that comes from another function, we want to kind of ignore everything but the basic thing. All right, so we're originally going to graph just sine of x. All right, we just learned how to do that. Highest value is 1. Lowest value is -1. We have our quadrants. And then when sine starts at 0, goes up, comes back down, goes back down, goes back up. All right, so that's my graph of sine of x. And now we want to graph sine of x minus 2. So we just know this minus 2 thing just moves all of our graph down 2. So this point's going to move down 2. And that'll be at -2. This point move down 1, 2. This point will move down 1, 2. This point will move down 1, 2. Now that's down there at -3. And this point will move down 1, 2. Of course, every other point is moving down 2, but these are kind of like the extreme values. And then we can see our new graph is going to start here, go up, down, and up. All right, so you can see it's the exact same sine graph, just shifted down. All right, but there's this interesting thing that happens with sine and cosine because there are these waves. The original sine graph, the x-axis kind of cuts directly through the middle of the wave. Like half the waves are above it, half the waves are below it. And when we shift down, this middle line is also going to shift down as well. 1, 2. So you can see now at -2, half the waves are above this line, half the waves are below this line. All right, so this value at -2, we're going to call the midline. Why is it called the midline? Because it's a line through the middle of the graph. And you can see that this value exactly matches up with this value. So we can actually graph these transformations of sine and cosine a little bit quicker because we have this idea of the midline. All right, so you can pause the video and write this down, but basically the midline is going to go straight through the middle of that graph. And we're going to have the same shape, just in a different location. All right, so can I graph cosine of x plus 3? All right, so cosine normally kind of starts at 1. All right, but everything's going to move up 3. So I'm going to move this point up, 1, 2, 3. This top part is going to move 1, 2, 3. So now I need to go all the way up to 4 for my graph. The midline is going to be 3. So I'm going to put this line straight through here. Again, on your graph, this should be dotted because it's not part of the graph. It just takes me a lot longer to make a lot of straight line dots. But that's our dotted midline. And we basically draw the exact same cosine graph we always do. So cosine starts above the midline. Actually, let me draw the normal cosine graph. The normal cosine graph looks like this. Look at that. All right, so we're thinking about it in relation to the midline. So cosine starts above the midline. Then at the next tick mark, it's on the midline. The next tick mark, it's below the midline. Next tick mark, it's back on the midline. Last one, it's above. All right, so it's the exact same general shape of the cosine graph, but with that new midline. All right, so that's the graph of cosine of x plus 3. Again, with cosine graphs, I like to do a little curve back down to show this wave. It doesn't go up that way. All right, it's going to keep waving itself forever that way. All right, but you don't need to include that in the graphs that we're doing. All right, so basic idea, move the midline to whatever that number is and do the same shape. If this was the exact same problem, but it was sine of x plus 3, do the same thing and have the midline. Sine starts on the midline, goes up, midline down, midline. That would be the graph for sine of x plus 3. So here's one for you to try on your own, sine of x plus 1. So go ahead and pause the video, try that one. I'll show you the answer in 3, 2, 1. And this is what your final answer should look like. So the midline is 1. So at 1 we had the midline. Sign's going to go 1 higher to 2 and 1 lower to 0. So it's actually really important that you get this point down here, not having it look something like that or something like that, because we know that this goes down to 0 is going to be the lowest value. All right, and then sine, same shape you would have had with our original sine graph. All right, up and back down, but just shifted to this new midline. Apparently there's no important points. The midline is the important part for this thing. It's called the video. Make sure you put that midline down first. Again, it should be a dotted line, but it's just harder for me to make nice dotted lines on the tablet. So dotted line, and then just remember sine starts on the midline and goes up and back down. Again, if this was the same type of question, but it was cosine of x plus 1, the midline will still be at plus 1, but cosine starts off the midline, then goes to the midline, then goes to its lowest point, then goes to the midline, and there. Another common mistake that students make is not using the tick marks. The tick marks are there to represent where those important values happen. So some people move the midline and then their final graph will look something like that. Even though these tick marks are here, this is too squished. You need to make sure that you're lining up this high point with that first tick mark, the next with the tick mark, the next extreme with this tick mark, the last extreme with that tick mark. Make sure you're using the tick marks to your advantage, and that's why they're on the graph, or else everyone's graph would look different. They'd all be different lengths and stuff like that. The tick marks are there for a reason, so we know kind of where those extreme values happen and when we should hit the midline.